Merhaba. Here I'm going to start my homework by compiling in Kale's Vision. So let's start our homework. Let me show you firstly my homework. My name is Ali Muhammad Ali, and here is my number. So we will use our last digit number of student number. So 8. We have to remind. So here is my homework. Firstly, we are going to implement move command by using address and data. As I said, my last digit number of student number is 8. So 8 plus 10 is 18. By the initial address is 18x and initial data is 18x. So by starting 18, we are going to until 0 hexes. So let's start with Kales. Let's compile. First of all, we are using ORG 00 hex and sjump x. Sjump x is just to start the label. Firstly, we have 18 data. It moves right in the address 18 hex address until 0. So the same instruction will be compiled from 18 to 00 by help of move command. At the end, we will have jump and end. Let's see if there are errors or something. Let's run it. So as we see, we don't have any error and no warning also. So to get the output from Kale, so we are using debug option. Okay. We'll wait a few minutes. So let's see disassembly. First of all, we have 18 data is transferred to 18 address. So at the same instruction is going until 00 hexes. At the end, we have also 00 hexes is transferred to 00 data is transferred to 00 hex. So these instructions show us 75000. 75 is the last byte. So in the question we have how many bytes is occupied by the program on Kales. So how do you show? First of all, as I said, my initial number is 18. So for 18, 3 bytes. We have to use move instruction. We have 3 bytes. We are using 3 bytes. Move and operand, first operand and second operand. So we have 3 bytes. 3 by 18. So we have 44. And as we know, sjump has first byte. First byte is occupied by sjump, and all other is 45. At the end, we have also sjump. So I think it's 56. 56 byte is occupied by program memory. So let's see memory. First of all, memory. So I'm going to compile 0 multiplied by 00. So here we have, we are starting from 18 to, why we are starting from 17? Because at the first we have 18 and then it's going down 17 and then 16, 15, and then at last we have 00. So to see the RAM, we are going to compile with D 0 multiplied by 00. Here you have 00. It means that by default it becomes 00. So we don't have any data or any address in this area. So that's all for first question. So let's move to second question in the homework. So by using DGNS comment, and indirect addressing for the first question. Again, the same question we will do another way. So here, let me open my screen, Kale screen. So new project. I have to debug because we are going to get another output. So I'm going out from this project. Yes, open new project. Then question one. Yes, question one. No, homework one. Because question one is first question. Here we are using more comments because of we need to decrease the instruction. If we need to increase the instruction because we don't want to use all those bytes. By using here we have at the first level we have to select bank 0. So how do we select bank 0? So as we have 00 hex data means 000 at bank PSY program statute words 00. So we are 0 bank is selected. Why we are using why we select bank 0? Because we want to decrease until 0 bank. So if we use bank 1 or bank 2 or bank 4, so we cannot compile this kind of instructions. So why we have to select bank 0 at the first. Second instruction is move. We have move also. We will compile in the product, but I'm trying to explain first of all. So we have 18 hex is moved to R0 register 0. 18x is located at bank 3. How? Because 1 it's bank 3 is selected. When we have 1 in PSY 4 and 3, bank 3 is selected, as we know. So firstly, I have to decrease address and also decrease data at as announced in the question. So firstly, I move the address to register and move data to accumulator. The same instruction for the first level. Second level, what we are going to do. So we have to combine this address and this data together because we want to decrease at the same time. So first of all, accumulator we have 18 and R0 is pointed to the address. So data is located in accumulator, but this data is pointed to the address of register 0. So the data accumulator is 18 is pointed to the address in register 0. And then so we are going to decrease this accumulator. If it is 18, it will become 17. And then we have decrement comment. Decrement comment means it decreased by decrement by 1. And we have also DGNS. DGNS means decrement and jump if not 0 to X level. So what we are going to show R0, with our R0 has 18 hex address. So it will decrease the level by 1 and also jump to another. If not 0, if it's 0, it will stop. So this is our loop. At the end, we have sjump2. Why we are going to use sjump2 is to repeat the same instruction. Okay, let's get output. Okay. First of all, I did not make any compile for if there are error or not, but I think there is no error because I try many times. We see in the output. If we got output, it means that it works. So we got output as you see. We have several numbers, and at the end we have 80. So let's see the disassembly. So first of all, as we say, we have sjump, and then we are going bank 0 is selected, and bank 18 hex is located at bank 3. So first of all, we started R0 register is located at 18 hex addresses. So R0 is not equal to 18, but it's equal to the address of 18. And accumulator, we have also data, 18 data, it moves to accumulator. So these two instructions will help us to use deg and deagenese commands. So first of all, we got A and R0, as we say, the decrement and jump if not 0. So here you see the disassembly structure. So let's compile it instruction by instruction. 0 program, we have 0 at 7, as you see. So let's move to another instruction. So here we have what? It becomes 0, but R become 8. R should become 18 because, yes, R0 it moves to the 18 address, it moved to R0. So you will see the change. You see, we have in the sixth stage we have, yes, in the sixth stage we have 18. So let's see, we have to, because here we don't choose anything, because I think we have to make it decrease. We have to see 10 times. So now we are going to see the loop 10 times. We start from 10. It's randomly. So let's compile it from 6. Yes. Yes. Accumulator is 17, 18, and R0 is 18. It should be also 18. So let's compile, because I went from 18. Let's compile again, because I don't want to mix you. Yes, sorry. So as we say, I will edit 18 by 10. I don't want to see 80 times. We will choose 10 or 11 as we want. Yes, 10. It's okay. So what we have, we are starting from S jump. Yes, I'm not going to show you all this steps because we don't have time. I have to make it short. So first of all, we have to go from S jump. R0 is 18. Let's show R0 is 18 or not. Yes. Yes. I become 0. A become 18, and 18 data is transferred to A. So let's move and decrease by 1. It will be decreased by 1. It's 18, as you see on A level. It will be decreased by A. It becomes 17, as you see. It will repeat 10 times. The same loop will be repeated 10 times because I added 10. So you see 17, it will be S13 state, because I pressed 13 times. It becomes 16, 15, 14, 13, 12 until 0. 0, it becomes 00F. The accumulator becomes 00. And as we know, in this instruction, what we put R is the data in accumulator is pointed to R0. So we have 00 in accumulator. So that's the end of our homeworks. Thank you for listening.